Let's go through activity 4 where we get some practice writing our own custom functions. So question number 1 wants us to write a function called hello world that takes two arguments, name and day of week, and it wants us to print out a message to the screen that basically says, hello name, have a great day of week. Alright, so for any sort of function or for any sort of complex programming task, I always recommend trying to get the code working for a specific instance before trying to generalize it. So in this case, since we know that our two arguments for this function are going to be called name and day of the week, I'm going to go ahead and actually try to get this function working, or this code working, for a particular set of values for each of these variables here. So I'll left arrow name to Adam, and I'll left arrow day of week to Thursday, define these, and I'll try to get it so that the message prints out to my satisfaction. So we're being asked to use cat and paste to accomplish this message. So let's see how we can actually go about doing this. Well, paste will go and take a bunch of text characters, basically, and paste them together in just one single string here. Now, the nice thing is that we can also give the names of variables if we want, and it'll automatically insert those as part of our text string. So we can see that the way that we're going to construct our message is by basically using paste to get the name and day of the week in there. Alright, so let me just copy the message that we're currently wanting to get in, which is hello name, have a great day of week. And I'll put that inside the paste parentheses. Alright, so what I need to do is actually replace name with what's contained in the variable name. So I'm going to replace that with just name. I'm going to end the quotes with hello there. I'll separate that with a comma. Then put in a new set of quotes for have a great, and then I need to put in the variable for day of the week. I'll put a comma, and then I'll put another quote and the exclamation point, the way to end off our greeting. So now, if I print that out, hello Adam, have a great Thursday. So I'm doing pretty good. The code seems to be printing out the message for this specific instance, so let's try to generalize this and make it a function. Alright, so to make it a function, we're going to give the function a name, hello world, and we're going to left arrow that to just function, parentheses, and then I'm going to put the code that I just written inside the curly brackets. And now we got to figure out what else do we have to do. Well, the function is to take two arguments, name and day of week. So I'm going to put those inside the parentheses so that the user has to specify these two quantities when they run this function. So what happens when the user runs hello world? Well, that mini universe is created. What will happen is that it'll inherit all of the objects that are currently defined in the environment. The first thing that happens is that these two variables will be left arrowed to whatever the values the user passes to the function, and then the code inside the function will end up running. So let's go ahead and define this function. We'll see it appear in the global environment as well. And let's try running it for a specific case here. So let's say hello world, Adam, and Thursday. And let's see if we get out the results that we want. Alright, looks like that's what we expected. Well, what about Canon and Sunday? Does that work? Yep, it works just fine here. So what's nice is that even though we have variables called day of the week and name defined in the current working environment, remember as soon as that function is called, it creates that mini universe and then runs the definitions for the function arguments. So name is going to be left arrowed to Canon in this case, day of week is going to be left arrowed to Sunday, and that'll overwrite the values in the current working environment. And so the function will run appropriately. Now, what happens in the function stays in the function, so once the function terminates, we return back to the working environment, and day of week and name are left unchanged at their current values here. So you might say, okay, well, why did I say use cat and paste to accomplish this? Well, I could have said cat paste, put a carriage return at the end of that expression, and essentially had it done the same thing. We'll notice that the output is exactly the same in this case. In general, if we want to paste together various strings to make an overall statement, using cat and paste together is the way to go, because then we have a bit more control over where we want the return characters to be and the way their output is going to look. So I'm going to highlight this and re-indent this so it looks a little bit prettier, and then move on to our next question. All right, so question number 2 asks us to write a function called csum that takes an argument x and returns a vector of the same length whose ith element is the sum of the first, second, all the way up through the ith elements of x. So this is like a cumulative sum here. And like with all functions, I'm going to recommend trying to get the code working for a specific instance before actually writing the entirety of the function. So looking forward, we see we're going to be testing this function with this particular vector. We're going to be having that function take the argument called x. So I'm going to go ahead and test my code by just defining x to be this vector. All right, so what I want to do is basically have that function return a vector of the same length. And if I look inside that vector, I want to be returning basically the sum of the first, second, third, all the way up to that element of x, the sum of those values here. So why don't I just choose, rather arbitrarily, I to be equal to 4, and see if I can get the sum of the first 4 values of x. Well, I can do that without much problem. I can take sum of x and then bracket with 1 colon 4. That way, x1 colon 4 are going to be the first 4 elements of x, and sum of that will take the sum of its values. So, all right, I'm going to be doing this for I equals to 1, I equals to 2, etc. I see this is a perfect chance for a for loop. So why don't I write a for loop to help me out with this? All right, well, I need to be looping over the numbers 1 through, well, however many elements are in the vector x here. I'll have to do that for each element. What do I want to do at each position? Well, I want to store the sum of elements 1, 2, all the way up to whatever I is. So I want to look at the elements 1 colon I, the abbreviation for that integer sequence 1, 2, 3, 4 up to I. And I want to be storing that into some vector that I'm going to be keeping track of these results. Why not just name it results? And because I'm going to be looping through values of I, I'm going to put into the very first element of results what the computation equals for the first time through the for loop when I is equal to 1, the second element into the results when I is equal to 2, etc. All right, so I'm going to get rid of both of these guys here. I don't explicitly need that. Let me make sure x is defined appropriately, and let me try running the for loop. Now, this isn't going to work. Error. Why did that happen? Well, I'm trying to put something inside the vector results, but R isn't aware that this vector exists yet. I can't do that. I need to actually make sure that the vector has been initialized, R is aware of it, before I can put stuff into it. So I'll initialize results to be just nothing, and I'll put elements into it one by one with that for loop. All right, so let's take a look at what the result is. All right, we have that our cumulative sum is 1, 4, 10, 12, 14, 22, 22. That's exactly the output that I'm hoping for. So it looks like my code works for this specific instance. So what I need to do is just to generalize this so that it works inside of a function. All right, well, I want the function to be called csum. I'm going to write curly brackets and put all that stuff that I just wrote, and then modify the code so that it'll work inside this function. Now, the function just takes a single argument, x here, which is kind of nice because I wrote my example code basically defining a vector called x to be a particular set of numbers. So what do I actually have to do? What do I have to change to make this work inside the function? Well, nothing actually. For best practices, since I want to return the vector of the results, the cumulative sums for each element of the vector x, I'm going to explicitly put in return here. And that's really all that was required in this case. Since I wrote my example code in a general enough fashion, I can pretty much just put that immediately into my function. Oops, I didn't want to comment. I wanted to re-indent that to make it look pretty. And my function should be good to go. So let's define that function. Let's run it with this example vector. We do get the output as expected. So we could run the command that you needed to do for inputting the number onto Blackboard, and this would have been the result. All right, question number 3 asks us to write a pretty useful function called scale01 that takes its argument, a vector x of all numerical values, and returns a vector where each value has been scaled between 0 and 1. Now, when we start to do clustering, it helps if every variable is more or less on the same scale. That way, each variable is on equal footing. So if we have some variables ranging between 0 and a billion, others ranging between 5 and 10, well, it helps to rescale them so that everything just lives between 0 and 1. So the variability in one variable isn't way more than the variability in others. So this will be a pretty useful function. What do we need this function to do? Well, basically take that vector x and to apply this transformation. Basically take the values in x, subtract off the minimum, and divide by the difference between the max and the min. That's going to scale the numbers between 0 and 1. Just so we see how that works, well, let's get the code working for a particular vector here. Why don't we just use this vector, and let's just see what happens when we use this transformation. So x are those numbers, I do this transformation, and I see sure enough that all the values are between 0 and 1. So if I want to make this code work inside of a function, well, let's set it up. Scale01 is the name of the function. I'll left arrow that to function, parentheses, and then in my curly brackets, I'll put the code that I currently wrote. The function wants to take an argument x, so that'll be the one argument in here. I don't need to define what x is inside the function. That'll happen automatically when the function is run based on what the user has passed as the argument. And all I needed to do basically is to return this computation. So I'm just going to wrap that inside of the return function, and I should be good to go. So there's my scale function. It's now in the environment. And if I define a vector z to be these values, run scale01 on that vector, I see that I get the expected result. All right, now the bonus part to this question is asking us to generalize this so that the values range between numbers a and b instead of 0 and 1. Now there's an easy way to do this. If we've already scaled the numbers between 0 and 1, all we need to do to make it scale between a and b is to perform this computation. All right, so at this point, we can probably just directly jump into the function writing itself because there's not too much code that we need to modify. Let's go ahead and set up that function, scale AB, left arrow it to function, parentheses, curly brackets. All right, so what does scale AB need as arguments? Well, it needs the numbers that we're scaling, we'll call it x, and it also needs to know, well, what are the lower and the upper limits. So it needs to know what a and b are, depending on what the user requests. All right, so what do we want this function to do? Well, the first thing that we need to do is basically scale it to values between 0 and 1. So let's create a variable called scale.x inside that function to be, this magic thing that we just wrote previously, which will take the values of x and make sure that it goes between 0 and 1. So this scales x between 0 and 1. And then our result, I'm just going to call the variable result. You can name it whatever you want. I basically am going to take scale.x and just apply this transformation. So this will scale between a and b now. And then I want to return that result to the user, so I put the name of the object that I want to be spitting back inside the return statement. All right, so I should be good to go. Let's define that function. We have our vector z from before. Let's redefine that, and let's just confirm that our function works. And it doesn't. So what happened here? What's the bug in our code? Well, if we look back, it's saying object scaled x is not found. So that seems weird because didn't I just define it? Well, no, I have a typo. I just said scale.x instead of scaled.x. So once I fix that, I need to redefine the function. And now I see I get the anticipated output. Great. So let's actually make this function even more useful by having it work on a data frame, basically systematically going through each column of the data frame and scaling the values inside those columns to be between 0 and 1. Now, obviously, since we can only do this for data values that are numeric, we're actually going to put in a stop function so that we get an error that tells us, hey, I can't do it on this data frame if it happens to contain a categorical variable. So the hint says to write a for loop. Why does that make sense in this case? Well, we want to go through systematically each column of our data frame and essentially do the exact same thing to it, apply that scale O1 function that we wrote. So there's no need to, copy and paste a whole bunch of code that manually does it for each column. We'll just write a for loop to go through each one automatically. All right, so what we need to do for each column is to make sure that it is a number, see if the class of that column is numeric, integer, or logical, true or false, but that's just 0 or 1. And if it is not numerical, that's when we're going to run into the stop message. All right, so how do we write this function? Well, we should probably get the code working for a particular instance first, and then see how we can generalize it. So, since we're being asked to test this on the ex3.abalone data frame, let's use that. So it lives inside library reg class, so I'm going to go ahead and load up library reg class, load up the ex3.abalone data frame. And looking back, since I want my scale O1 df to take the argument data, I'm going to go ahead and actually just define data to be the ex3.abalone data frame. All right, so let's get the code working for this particular data frame and then generalize it. So we know we need a for loop because we need to go through each column of our data frame. And my recommendation, if we have to write a for loop, is to write an example piece of code that gets it right for one particular iteration in that for loop. So, all right, if we're going to go through column by column, let's just arbitrarily choose column 4. I'll set I equal to 4 to represent the column number, and let's scale the values inside column 4. All right, well, we can only do this if it's numerical, so we need an if-else statement. We're only going to do this scaling if we can get away with it, if we have a set of numbers here. So we're going to need an if-else statement here. So let's fill in the pieces of what each part needs to be. Well, I need to check to see if it is a numeric column. I can do that by checking the class of that column. So data bracket blank comma I will refer to the particular column that I'm at right now, the 4th in this example here. And I need to make sure that it is numeric, or it's integer, or it's logical. So I could write this as a whole sequence of or statements, or I can use my %in shortcut here. So let me type out the vector of values that I'm okay with, numeric, integer, or logical. And what will happen inside this if statement is it'll extract the type of object that the ith column of data is, and it'll check to see if that type lives inside this vector here, if it's numeric, integer, or logical. So if I is equal to 4, we can check to see, all right, well, what is the class of the 4th column here? It's numeric. We see that it appears in one of the elements of this vector. So if I evaluate this expression, it will evaluate to true. All right, well, what do we want the code to do if this evaluates to true? Well, we want to scale that column. So I'm going to take the ith column of that data frame and essentially just apply my scale O1 function that I've written. It's in the environment, so I know I can use it. Scale O1, the values inside that column. All right, so that's the only thing I need it to do. What do I want it to do if it's not numeric, if it's not one of these 3 types of objects? Well, that's when I need to print out the error message. So inside the else statement, what's evaluated when the if statement is false, I'm going to say stop and put in the message that I want to return. This was the message that's requested. Basically cannot scale a data frame with a categorical variable. And so I should be good. All right, so my example case right now is working with the EX3 abalone data frame, specifically column I. So let's just run through this. So I is equal to 4. We find that this is true, so we end up taking the data values in column I, column 4, and scaling them between 0 and 1. Okay, well, now I want to do this for each column, so here's my chance for my for loop. So what am I looping over? Well, I'm going to loop through numbers 1 through the number of columns that I need to go through with my data frame here. Since I arbitrarily defined I to be equal to 4 here when doing my test code, it's, might as well just reuse that notation right here. So I don't need I left arrow 4 anymore. That'll happen automatically as we go through that for loop. So what will happen is that for each column in the data frame, we check to see if it's numeric, integer, or logical. If so, we scale it. Otherwise, we print out that error message. So I can end that for loop by closing this curly bracket, and I should be good to go. So let's see if this succeeded. All right, so let's define data to be ex3 abalone, run through that for loop, and all right, we want to see, did we successfully scale each column to be between 0 and 1? Well, I can very quickly figure out the answer to this by, well, let's just look at the summary of data now. We see the minimum values are all 0, the maximum values are all 1, so it looks like we successfully did this. All right, well, we should also check this for when we run into an error here, when the data has a categorical variable. Everything in the abalone data frame is numerical, so we wouldn't get any errors here. The tips data frame, however, does contain non-numerical information. If I load up the tips data frame, I see I have gender, smoker, etc. So I want to make sure that my error message works. So I'm going to go back and now set data to be tips, and I'm going to run through this for loop. And indeed, it does say error cannot scale the data frame with the categorical variable. All right, so it looks like it works for data frames that just have numbers and data frames that have categorical variables. So let's generalize this code that we've written and have it live inside of a function. All right, so what I'm going to do is to give the function the name, which is scale o1df, left arrow it to function, parentheses, and then all the code that I've written here, I'm going to put inside curly brackets, and I'll figure out what I need. All right, so it needs the argument just data here, the data frame we're doing this to, so I don't need this data left arrow tips. The user is going to specify what data frame. I'm basically going to go through each column of the data frame, and if the type of column is numeric, I scale it, otherwise I print out that error message. So, all right, are all my parentheses or curly brackets balanced? Yes, this very last one matches up the curly bracket up here. I can highlight this code, go into code, and re-indent lines to make it look a little pretty, take out some spaces, but it looks like I'm good to go with my function here. So let's go ahead and remove that little part. Let's define our function, and let's go through the test cases. So here is where I'm going to load up ex3.abalone, and we're going to save the results of scaling ex3 abalone to a new data frame called scaled abalone. All right, if I do this, I can check to see, all right, does it look like it successfully operated? I can look to see what the average is for each column, and oops, I get an error message. Why could that be the case? Well, let's do some investigation. If I go back into my data frames, I see that, well, scaled abalone right here is null. There's nothing. So what went wrong here? Well, if we look back in my function, we see that we never actually returned anything back to the user. So we did a lot of things to the data frame that was passed as the argument, but then we essentially held it hostage inside the function. Once that function is done, that mini universe that ran all the code goes away, and all those great results vanish. So we need to make sure to return the data frame to the user. All right, so let's update our function. Let's run that on the abalone data frame, and let's look at the average value inside each one of the scaled columns. And I give a hint that says, all right, if you do this, you should find the average length is just about 0.65. So that looks reasonable. I'm pretty happy with that. What if we try scaling it on tips? Well, we get that error message saying, nope, can't do it. Can't scale a data frame with a categorical variable. All right, the bonus has us generalize this code just a little bit to be somewhat more informative with the error message. Because when it says cannot scale a data frame with a categorical variable, well, we'd like to know which was the offending column here. Now, we could do that investigation on our own, but wouldn't it be nice if the function just told us that immediately? So let's improve this error message here. I'm going to put some return characters here and figure out, all right, how can we improve this error message? Well, one thing I know is that I can get a column name of a data frame with the names command. If I say names tips, for instance, this gives me a vector of column names right here. And so if I do end up basically quitting this function because of this error message, I is going to be equal to the column number of that offending column. So if I said something like names data I inside the else statement, this will contain the name of that offending column, and I'd like to return that back to the user. All right, well, there's the use for the paste function. I can take a bunch of character strings, paste them together to make one big string. So instead of having the message just be this, why don't I capitalize this C and actually paste together a bunch of things. So I'm going to paste this message together. Cannot scale a data frame with a categorical variable. I'm going to put a colon. And then I'm going to put a comma and actually have the name of that offending column be contained in the message. So cannot scale a data frame with a categorical variable. This particular column name, I'm going to put a comma and continue the message, is a categorical variable. All right, so this parenthesis ends the paste. I need another one to end the stop. I can redefine this data frame or redefine this function. I can make the code look a little bit better or not. And now I can try running it with the tips data frame. Cannot scale a data frame with a categorical variable. Gender is a categorical variable, and we see that gender is the very first categorical variable it runs into. So somewhat more informative, a bit useful, especially if you're writing code that other people are going to use. Having as informative error messages as possible is definitely good practice. All right, question number 5 wants us to write a function called best scores, which takes two arguments, a vector x that contains homework scores and a number dropped. So what is this function going to do? Well, it's going to return the average value of x after the smallest dropped elements have been eliminated. So it's essentially like how homework works in this class. We're going to drop the lowest 2 scores, and we're going to take the average of the rest here. So one note is that the vector x may contain NAs, because every now and then in Blackboard, if you haven't submitted an assignment, the field is just blank, and that'll be interpreted as an NA by R. So we actually first want to strip out the NAs, then, or not strip them out, replace them with zeros, then figure out what the lowest 2 or dropped elements are, take them out, and take the average of the rest. All right, so how do we get this function to work? Well, let's write some code that actually does this procedure for a specific case. So let's try to get it working for our test case for this particular set of homework scores. All right, so since the argument is going to be called x, I'll just define x to be our little test vector here. And dropped, in this case, is going to be defined to be 2. Let's get it working for this case. All right, so the first thing I need to do is replace the NAs with zeros. How can I do that? Well, I can extract the elements that are NAs by doing x with square brackets to refer to the particular elements. So how can I do that? Well, there's a hint, which is .nax is going to return the positions that find missing elements. So if I just run this by itself, it says 2 because the second element is indeed an NA here. So because this is inside the square brackets, that'll refer to the positions of the vector x. So I want to replace, in this case, the second position with the number 0. So I can just left arrow that to 0. All right, we'll run that code. Let's see what's in there. All right, looks good. Now what I want to do is to take the average of the homework scores that remain after I drop the lowest 2 in this case. So how can I do that? Well, there's a few ways. Let's explore sorting the values in the data frame first. We see this goes from smallest up to largest. And so what we'd like to do is essentially get rid of these first 2 elements, or in general, the first dropped, whatever that happens to be, elements here. All right, well, how can I do this? Well, once again, I can turn on the square brackets to refer to particular elements, and there's a way to refer to everything but a certain set of elements here, and that's by putting in the minus sign, and then putting in parentheses here, basically a vector of element positions that I want to ignore. And in this case, I want it to ignore the first 2, but in general, I just wanted to ignore the first dropped values here. So the sequence 1, 2, 3, all the way up to whatever dropped equals. So right now, if I just print out the result of running this command, well, I got to define dropped. I see that it's taken out those first 2 elements, and I have the remainder, the ones that I want to average. So I want to be taking the average value of this, and basically that's going to be my result here. All right, so I got some code that works for this specific case. Let's write a function that does this. All right, so I give my function the name best scores. Left arrow it to function, put some parentheses, and then curly brackets around all the code that I've written so far. All right, so the arguments to this function are x and dropped according to the statement of the problem. And what do I need to modify inside the curly brackets now? Well, I don't need to x left arrow to anything because that'll happen automatically when the function's called. I don't need to define dropped to be anything. That also happens automatically when the function is called. But I do need to take whatever is inside the vector x and replace the NAs with zeros. So I'm going to keep that code. I don't need to sort x and just have it be printed to the screen. I actually want to basically take the results of sorting x and save it, resave it to the vector x here. All right, so now if I do that, that x will be the sorted values inside the vector x. And if I take the average of x minus 1 through dropped, that'll give me the average after dropping those lowest scores. So I'll define this function. Best practices says, all right, let's actually explicitly put inside of a return statement the object that I want to be returning. So I'll rerun this, and we can check to make sure that we get the right output. We do, so we can do the thing that Blackboard wanted us to input, and it looks like that's the right answer. Just about 89. You're supposed to round it to the nearest integer, so the answer for that would be 89. All right, question 6 looks like it's a really long question. It's not, it's just a lot of background information here. So we're about to do some sort of classification and clustering when talking about data mining techniques. And when we do so, we become obsessed with talking about how similar and how different individuals are to each other. So we'll be measuring similarity with some sort of distance, and if our values are numeric, well, we can calculate something akin to, say, just the ruler distance between them, the Euclidean distance. But what do we do if we have categorical variables? How do we tell the difference between, or how much distance is there between Tennessee and Massachusetts, for instance? So if I have two individuals, I have 5 values that are recorded for them: gender, state of origin, type of child they are, marital status, favorite sneaker brand. How far away are these two individuals? So distance and categorical variables, we need to invent a method to calculate their distance. And in this case, we're just going to do something very simple. So what our distance is going to be is to be simply the number of values inside of the two vectors that are different. So for these two individuals right here, well, we have 5 total pieces of information about them. We're going to say that the distance between these two people is the number of elements that they don't have in common. So there's 1, male versus female, middle child versus only child, Adidas versus Nike. They'd have a distance of 3. If we had identical values for everything, the distance would be 0 here. All right, so we're asked to write a function called distance categorical that essentially figures out the number of elements that aren't the same between its two arguments x and y. All right, so let's try to get this working for a particular set of vectors and then generalize it so it works inside of a function. Now, I'm already provided 2 vectors here, so why don't I just copy and paste this? And since my argument names are going to be x and y, I'm just going to rename this to x and y here. All right, so let's define x and y, and let's get this code working. All right, I have a note that says the first 2 lines inside the curly brackets for this function should read x left arrow as character x and y left arrow as character y. So let's just write that in here. The reason why we're doing this is because it might be the case that we're dealing with say some sort of levels of a categorical variable, in which case the type of object is a factor, or it might be the case that, all right, we actually have values that are numbers, but in reality they're levels of a categorical variable like 0, 1, 2, 3. You know, they could be levels, and we want to treat them as levels of a categorical variable. So as.character converts whatever object it currently is in to basically a vector of just text. Strips out the levels from it, and we're just going to be basically counting up the number of different elements between these two vectors. If it's still a factor, it's not going to quite work the same. All right, so we're just doing this because I said so, and now let's figure out the code to count up the number of different elements in here. All right, there's a lot of ways to go about doing this. So I'm going to try to do this as efficiently as possible and just ask the question, what happens if I were to say x is equal to y? Or x is not equal to y here. That's what we're really interested in. So if I type out x not equal to y, let's just see the results. I see a true, false, and true. All right, well, we noticed that male and female are different, so true. Tennessee and Tennessee are the same. They're not different, so false, etc., etc. It looks like if I run this command here, this gives me something I can work with. Since true is treated as 1 and false is treated as 0, I could take the sum of x not equal to y, and that'll actually immediately tell me the number of elements that are different between these two vectors. So putting on your thinking cap and trying to be clever can sometimes really pay off. It looks like that's the only operation that we need to do. So all right, let's try to generalize the code that we've written into the function. It wants to be called distance categorical, so we'll left arrow it to function, parenthesis, and then put curly brackets around what we just wrote. The two arguments are going to be x and y. And what do we need to change here? Well, we don't really need to change anything because we wrote our example code in a way that was pretty general to begin with. So basically we take the vector x, make it a character, take the vector y, make it a character, and then explicitly return the number of elements that aren't the same. All right, let's define our function, and let's run it with these two example vectors, v1, v2. Let's run distance categorical with v1 and v2. We get 3 out, as expected. All right, so on Blackboard, you were supposed to run this set of code here and get the answer 9631. Basically, you generated two random vectors that had 10,000 letters in them, and you counted up the number of elements in those two vectors that didn't happen to have the same letter. Most of them aren't going to have the same letter, so out of those 10,000, it looks like 9,631 were different. Moving on to question 7, we're asked to basically write our own custom versions of pmax and pmin. Now these are two useful functions because they return the element-wise maxima or minimum of two different vectors. So for instance, I had x and y defined as follows. Pmax of x and y is going to go through and say, all right, well, which is the larger of the first elements, which is the larger of the second, which is the larger of the third, and so I get 359 out. Pmin just does the same thing but for the minimum. So here we're being asked to write a function called pairwise and does something very similar. Take two vector arguments x and y and a third argument, up to us what we want to call it, that will either be min or max. And then the function to return a vector of the largest or smallest values of each pairwise element, very similar to pmin or pmax, depending on what the third argument is equal to. And we're asked to put an error message if the third argument is not min or max that says this specifically. Third argument must be either min or max. All right, so to write a function, let's get it working for a particular case first. Let's just use these two vectors right here. It's making our life easy. We want the function arguments to be called x and y, so we'll have x and y be these two vectors. And let's see what we can do here. All right, well, what we want to do is go through each element of x and y in turn and figure out, all right, which one's the max, which one's the min, depending on which one the user wants. So since we need a third argument here, I'm not told what to actually call this argument, I'm just going to call it choice. And in this case, I'm going to set it equal to min and just get it working for this particular example. All right, so I'm going to want a for loop that goes through each element of x and y and calculates the minimum. So in order to get the for loop working, I can either just write it all in one go, or I can try to get it working for a particular example. I'm going to set I be equal to 2 to represent the second element right now. Let's get it working for the second element of these two vectors. All right, so if we have that the choice is equal to min, then what we want to be doing is basically calculating what the smallest value is between these two vectors. All right, and we need to store that in some vector because we're going to be returning the results to the user here. So what this does, it says, all right, I is equal to 2. If we're looking at the minimum value, we're going to look at the smaller between xi and yi, the second positions of the x and y vectors, and we're going to store that in a vector called result. Now, before I can actually put stuff into a vector called result, I need to make sure it exists. Let's just see, did this work? Well, got to define choice here. So result is NA and then the number 1. Does that make sense? Well, yeah. If we look at the second elements, the smaller of those two is the number 1. I haven't looked at the first element yet, so there's nothing there. That looks like it's good. So let's wrap this inside of a for loop now. For I in 1 to length of x, do this for each element in x. X and y are the same length, so I can just use length of x here. I don't need to I left arrow 2. That'll happen automatically as it works through the for loop. But basically, all right, if we have the choice equal to min, then the ith element of result will be the smaller of those two values. All right, so I could actually need to generalize this more. If choice is equal to max, I need to do something different. So if choice is min, well, we'll take the smaller. Otherwise, the user must have put in max. I'm going to put in that the result is the largest value of these two here. So it'll be equal to the max. All right, so let's just confirm this makes sense. If choice is min, what's our result? 1, 1, 2. 1, 1, 2. Yes, that's the smaller of the pairwise elements. Let's change choice to max here. Rerun this. 3, 5, 9. 3, 5, 9. Yes. All right, so we're almost good to go. Let's go ahead and write this function now. We want the function to be called pairwise. Let's left arrow that to function, parenthesis, curly brackets, and put all that code that we just wrote inside the curly brackets. The function should take arguments x and y, and then a third argument, it's up to us what we call it. Since we tested out our code with the argument essentially being called choice, let's just reuse that. And let's see what we need to modify with the code that we've written. Well, actually, we don't need to modify anything at all. We basically set up result to be an empty vector. And then, if we go through each element of x and y in turn, essentially, if the choice was minimum, we store into the result the smaller, otherwise we store the larger value. All right, so looks like we're pretty good to go. So I'll go ahead and define our function. We'll try x, y, these values, and run pairwise for x and y. Now I'm not getting anything back. It happened again. So what's my error? Well, I forgot to actually return anything to the user. So I'm going to re-indent these lines. And the very last line, I'm going to say, by the way, dummy, spit this back to the user. That's what the user wants. So I'll redefine my function, run my code again, and I'm getting the answers that I expect. Now, wait a second, I'm not done because I wanted to output an error message if that third argument was not min or max. Because notice what happens if I were to say, pairwise x, y, choose, or cheese is tastier, it went ahead and actually just returned the maximum values of the pairwise elements here. Why is that the case? Well, choice wasn't equal to min, so it went ahead and executed the code inside the else curly brackets. So what I need to do is basically first thing in my function is to make sure the user has put in a valid argument for choice. So I need to basically say, all right, if the user's value is valid, actually do this function. Otherwise, stop and return that error message. So I need to see if choice is equal to min or if choice is equal to max. If that's the case, good for the user, they put in a valid argument. I'll put in curly brackets all that code that I just wrote. Otherwise, well, I need to output a stop message. If that's false, if they didn't put in min or max, I need to say stop, and the error message desired is this one right here. So I'm just going to straight up copy and paste that. And I'm going to make sure that this is okay. I'm not getting all these red arrows or red X's everywhere. So that's indicating that something isn't okay. It might be confused with these single quotes. So are we happy with that now? No. Oh, because I'm missing the quote right there. All right, the entirety of the error message has to be in quotes. And I think now with those quotes, I can actually go and sneak in the single quotes there as well. Okay, let's define our pairwise function once again. Now let's run it for these three cases. And there we go. The third argument must be either min or max. Great. Question number 8, the last one, asks us to write a pretty interesting function called replace missing that takes a single argument called data and replaces any missing values in each column with the median if the quantity is numerical, or the mode if the quantity is categorical. And we'll have the function return an error, not a data frame, if the argument's not a data frame, if the user tried to just put a number in there, or a matrix, or a vector. So, additional notes, data is only going to contain numerical or categorical variables, so we won't have like just a character column in there. All missing values are NAs. It's not like 999, blank, or anything like that. We'll use the class function to figure out if it's a factor or if it's not a factor here. And we'll use the function mode factor inside reg class to help us pick out the mode of a categorical variable. And lastly, if we're going to do the median replacement, we need to make sure to add in that argument na.rm equals true so that it correctly finds the median here. All right, so we're asked a lot of stuff to do here. So to get the function working, of course, we're going to have to go and make sure that it's working for a particular example first off. Now, I say to test out this function by running it on the ex7.catalog data frame after putting in some missing values by hand. So let's actually try to get it working for this particular data frame. So we're going to load up the ex7 catalog, we're going to set the random number seed, and we're going to do some modification of it where we just randomly put in missing values. So you'll notice if I look at a summary of the ex7.catalog, I have NAs in every single column. Some are categorical, some are numerical. So this is a good test object. All right, so let's get it working for this particular data frame. Now, I want the name of the argument to this function to be called data. So I'm going to take data and left arrow it to ex7.catalog. That way the code that I'm writing can immediately essentially be placed inside of a function. All right, so what do I want this function to do? Well, I want it to go through column by column, figure out if there are any missing values, and if so, replace them with the appropriate replacement here. So since I'll be going through systematically every single column, I know I'm going to need a for loop to do this. So why don't I go ahead and get the code working for one particular column of the data frame. And in this case, I'm going to get it working for just column number 1. So I know in my for loop, I'm going to loop over something, probably just the number I here. So I'm going to anticipate that and set I be equal to 1. All right, so what has to happen? What does my function need to do? Well, it needs to check to see if there are any missing values. So if there are missing values, we do something. If there aren't any missing values, then we don't do anything at all. So one thing we could do is check to see if there are any missing values. So I could say, all right, well, how can I check to see the number of missing values? Well, I can use the length, which is .na function, on that particular column. So let's walk through this one by one. We have I being equal to 1. Let's see how many NAs are in column number 1 here. 400. That's what the summary said as well. So if the length of the number of NAs is greater than 0, then we know that we have missing values and we need to do something. All right, so we're going to put something inside these curly brackets. What do we need to do? Well, that's contingent on whether or not this was a categorical variable or if it was a numerical variable. So let's write another if statement that helps us out with what direction we need to take. So if it's a categorical variable, replace it with the mode. If it's numerical, replace it with the median. So let's go ahead and check to see if it is a categorical variable by asking for the class of this column. In this case, we see it's a factor. So I'm going to say, all right, if it is a factor, we have a categorical variable. We need to replace any missing values with the mode. All right, now the nice thing is, with reg class loaded up, there's a function called mode factor that takes a categorical variable and reports the most common level. So we'll notice it says yes here. Does that make sense? Well, if I look at a summary of this column, we see that there are 1984 yeses versus 1616 nos, so that's giving me the appropriate value out. So if the column is a categorical variable, then basically what we need to do is replace all of those NAs with the result of running mode factor here. So I'm going to left arrow that into the specific locations inside the data frame that contain those missing values. So how can I get that? Well, I'm working with column I of the data frame right now. I need to specify which rows have missing values. So I can do that by just saying which is .na of this particular column. So this code is starting to look like a hot mess now. We have a lot of brackets. We have curly brackets, parentheses, everything. What's going on here? Well, if I just run this particular chunk before the comma, this is printing out the row numbers that contain those missing values. So these particular rows, the ones that contain NAs, in this particular column, that's the one we're currently working on. Let's take those and replace that with the result of running mode factor. So if we do this and now look at a summary of my data frame, we see there's no missing values anymore. All those NAs have been replaced with yeses. All right, so we've taken care of the case for when that column happens to be a categorical variable. Well, what if it wasn't? Well, we need to replace it with the median. So something very similar, we're going to take all of the rows that had missing values for that column of interest, but instead of taking the mode, well, we're going to be taking the median. So we'll look at the median of the values in column I with the additional arguments na.rm equals true, so that it actually will calculate that value. All right, so let's test this. Right now, I is equal to 1. We're actually working with the by column here. Notice quarters with purchase is a numerical column. It's the second one. Let's just change I equal to 2 right quick and make sure that we calculate the median correctly. Notice if we didn't have na.rm there, we would have gotten an na back, and we wouldn't have done any sort of replacement whatsoever. Okay, so it looks like we're good to go, at least when we have missing values. So if the number of missing values was bigger than 0, replace those missing values with the mode or the median, depending on what the appropriate response was, depending on if it was categorical or numerical. All right, so that took care of that one big if statement. What do we do if we don't have any missing values? What do we put inside the curly brackets after the else? Well, nothing. We don't have to do anything because nothing's missing. We're good to go. So in this case, we can actually delete the else because we can just have it move on. All right, I'm going to highlight this at this point and go to code and reindent so that the punctuation and the spacing looks a little bit prettier. All right, so we did this example for column 1 here, and we looked a little bit at column 2. We need to do this for every column. So basically, this is when I need my for loop here. I'll be looping from I equal to 1 all the way up to the number of columns in the data frame. I need to do it for each column. Put on the curly brackets, make sure I have another curly bracket that closes that off. And once again, highlight, and I'm going to reindent to make the spacing just look a little bit nicer. All right, so I'm doing pretty well. I can go through each column of data and replace missing values with the mean or the mode when appropriate. What's the other thing the function is asking me to include? Well, it's asking me to include a stop function here that outputs an error if we didn't actually input a data frame. So even before I do this for loop right here, I need to check to see, can I even do this? So is this a data frame? So if the class of data, that'll tell us what type of object is. If this is not a data frame, notice if I do class of data right now, it says, hey, that's a data.frame. If it's not equal to data frame, that's when we need to do that stop message. So we'll output an error to the user that says, hey, dummy, you tried to do this on something that wasn't a data frame. And you can't do that. It doesn't make any sort of sense. So we're going to have it return this error message right here. Leave out the dummy part, just not a data frame. And we should be good to go. We need to make sure this code is generalizable into a function, but that should be really no problem at all at this point. So here's all the code that I've written. Let's make this play well inside of a function by giving that function the name, replace missing. Replace missing, left arrow that to function in parentheses, and then curly brackets. I'll put all that code that I wrote in the curly brackets. We see that it's matched up here at the top. And then what I need to do is specify the argument, which I said was just the word data here, the data frame that we're interested in processing. We can get rid of the data left arrow line of code here because that's going to be automatically defined when the function is run, whatever the user put in. And do we have to change anything else? Well, nope, this looks good. If the class of data is not a data frame, we output that error message. Otherwise, we actually didn't need the else statement here. Otherwise, we just continue onwards and do this stuff. Otherwise, go through systematically each one of the columns in the data frame. If it has missing values and it's a factor, well, replace those missing values with the mode. Otherwise, replace those missing values with the median. And then what I need to do is make sure to give back this data frame to the user. So I'll return data, and I should be good to go. I'll re-indent these lines one last time. I'm going to define my function, and let's try it. All right, so here's my ex7.catalog data frame. I've already modified that so that it has missing values in it, and I'm going to run my function on the ex7 catalog data, save the result to clean. So I'm going to run my function, no errors, that's great. Get a summary of this. Notice I have no more missing values here. I will have successfully replaced all the missing categorical variables levels with the most common level, the mode, and replaced all the missing values that were numerical by the median. We can check to see if this will work. If I don't give it a data frame, replace missing, say the number 3, it's not a data frame, it can't work. So we're pretty happy. All right, so that concludes activity 4, writing functions. Very useful skill to have. This is what employers really, really want. This allows you to do custom analytics.